Well, it might be a slightly different page number for him. 40 in this book, yeah.
This is quite easy.
Oh, everything is quite easy if you know how.
Because my friend also already teach me.
Oh, good. Okay. Right. So, let's have a look at the maths now. Let's have a look. We'll have a look at the maths. So, to be clear, we're doing maths for the rest of the week now. Okay? So now, come on. You know that's wrong. Just for this week. Okay, so aromatic progression.
Yeah.
Imagine you have a sequence like 3, 5, 7, 9. The next one would be 11. So the key idea for aromatic progression is that you add the same number each time.
Okay.
So in this case, you're adding 2. So a few definitions here. A is the letter we use for the first term. And in this example, what would that be? 3. And D is what's called the common difference, which in this example is 2. Okay. Now, before I continue, we'll have to do some formulas for this.
Yeah.
Okay, can I scroll down?
Yeah.
Yeah, okay. So let's look at what the sequence looks like.
Sorry, the first one we did, does it come out in the exam?
Which one?
The very first one we did under series.
Hang on. Oh dear.
Are you okay?
That's 3 times today.
I have more.
I'm okay. I'm okay. Right, sorry, what were you asking me, Bello?
The first series we did.
In the earlier lesson?
Yeah.
No, in the exam, they tend to stick to aromatic and geometric, but sometimes they do give you, like in the last lesson, a question like in the last lesson, where they ask you to add up some terms.
Okay.
Yeah. 90% of the time it's aromatic or geometric.
This is done, that makes sense.
Yeah, this one is easier to understand. So, if we have an aromatic sequence, the first term is going to be A. What would be the second term then? A plus D. And the next one? A plus 2D and A plus 3D. Now, if you call the first term U1, and this is U2, U3, and U4,
Yeah.
if you look at the pattern here, I think you can figure out what the formula is for the nth term.
Yeah.
A plus
N negative.
Not ND, Ming.
N minus 1.
N minus 1D.
D. Yeah.
Yeah? Okay.
Easily.
Right. So write that down and we'll have a look at some examples. Okay, example 1. I want, this one's quite easy. Find A and D in the aromatic progression. Minus 4, minus 13, minus 22. AP is short for aromatic. All right. So, what's the A here?
It's
Minus 4. And the D?
D is 9.
Yeah, good. Minus 9, yeah.
Yeah.
I could hear your brain calculating that. Okay, is that all right for the first example here? Yeah. Easy enough, isn't it? Right, second example. I want you to find the nth term in the AP minus 1, minus 6, minus 11. Right, so if we use our formula, UN is A plus N minus 1D. What is A?
Minus 5.
And then D?
That's minus 5.
Minus 5. So this will be minus 1 minus 5N plus 5. And so this will be 4 minus 5N. Yeah? That is the nth term. So for example, the 10th term would be 4 minus 50, which is minus 46. Yeah? Okay. Can I scroll down?
Yeah. Keep going.
Now we start getting on to slightly harder ones. You sleepy, Ming? No. Are you bored? No? Then what are you? Just Ming, okay. Right. How many terms are in the aromatic progression minus 9, minus 11, minus 13, dot, 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 finishing at minus 45?
It is me.
Now, how can we do this one?
Because there's
Yeah, the trick is you make un
yeah.
equal to minus 45. And in this way you can figure out what the n was to make the last term. So, using our formula, a plus n minus 1 times d, which is minus 2, that should equal minus 45.
Yeah.
So that means n minus 1 times minus 2 should equal minus 45 plus 9, which is minus 36, isn't it?
Mm-hmm.
Yeah.
Then I'll divide by minus 2. So what do I get here? Do I divide by minus 2? Try again, Rahman.
18.
18, thank you. And so what will the n equal?
Then it's 19.
19. 19. 19 terms. Okay?
Yeah.
Yeah. Okay. Have you got this one?
Yes.
Yeah. Can I scroll down?
Yeah.
Rahman? Yeah, okay. So, example 4. I tell you that the 10th term is 11 and the 16th term is 17. And that's enough information to work out the A and the D, which is what I want. So, find A and D. Yeah, actually, you can see D is 1, isn't it? This is 6 terms later. Okay, so let's pretend it wasn't an easy number like this. How would we do it? You would say the 10th term is A plus 9D. And that should equal 11. And the 16th term is A plus 15D. And that should equal 17. Well, it's simultaneous, yeah. So 6D equals 6, so D equals 1. If I sub that back in here, I can get the A. What's the A?
It's 2.
2. That's the answer.
But verify to the 15 and the 9.
N minus 1, N minus 1. 10th term. 16th term.
Yeah.
Is that okay? Is that okay?
Yeah, it's quite difficult to understand how you're able to solve this so fast.
Because he's a genius.
Thank you.
Just accept it and move on. So you have a lot of doubters in this class. I don't know why.
Don't worry, after the midterms you'll understand.
Yeah. Wait till you see him getting more than 100% in the test. Yeah. Right? Yeah. Yeah. Look, haters gonna hate. Yeah. Look, hang on. Jealousy doesn't suit you, okay? Just focus back on the maths now. Right, okay, did you write that down? Yeah. So the next one now is we'll have to do a second formula. There's 2 formulas for this lesson. So I think some of you could probably guess what the second formula will be about for this lesson. The sum. So if I scroll down, what we want to look at now is calculating the sum of the first n terms. That'll be u1 plus u2 plus u3 all the way up until un, like that. Okay? Now this one is the proof is a little bit tricky, but it's not too bad. It has a special trick to it. So Sn will be a plus, and the second term is a plus d, and then the next term is a plus 2d, and then what's the last term here? A plus
nd.
No, n minus 1 d. Now, does anybody know the trick for simplifying this? You do, Marwan? No, not this. That's something else. Does anyone else know the trick for simplifying this? You do? Can you say it, or yeah? Anyone who can speak, can they tell me the trick? No? No one knows the trick that can speak? Yeah, hang on, Ming's telling us, go on. Oh, I don't want the final answer. I want the step. So the trick here is you write the sum out again, but in reverse order. So you start off with a plus n minus 1d, and then you have the next one, the next one, the next one, and then you finish all the way down with a plus 2d plus a plus d, and the last one here is a. And then you add them together. Now something interesting happens here. So Sn and Sn is 2Sn. Now you can check this out. When you add these together, you'll get A and A, so that's 2A. And is there any n's here? No. So you end up with this. Okay. Now I won't go through each one, but you can check a couple of them and you'll discover that when you add the second one and the second one here, you'll get the same thing. In fact, why don't we just jump all the way down to the end? When you add these together, again you get 2a plus n minus 1d. They're all going to be the same. So what is the quick way to add many numbers together that are the same? What do? You multiply them. So what would this be? This would be n times 2a plus n minus 1d. So we're nearly finished. What's left to do? Divide by 2. And you get Sn equals n over 2, 2a plus n minus 1d. What? What? You recognize the formula? Yeah, okay. Right, write this down and then we'll do some examples of using this. No, but it's still good to see. How many of you think you've seen this proof before? Now that you've seen it again, you think you've seen this before, the proof? Okay, a long time ago, was it?
Just
Last year, they actually showed me in primary school, but it was wrong.
how many are secondary?
No, like primary 5, but like
AP and GP.
one of the school's husband was quite a kid and accused the teacher all the kids.
Okay, okay.
Five.
I don't need your life story. It's okay. Right, can I scroll down? Do you have this? No. Hang on now. Just chillax, okay? Just chillax. Right. let's have a look at some examples. So, what number example am I on now? This one's number 5, is it? Example 5. So, I want to calculate the sum of the first 40 numbers in the series minus 4, minus 2, plus 0, plus da, 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 all the way up to 78. I want to add all those numbers together. So I'll just use my new formula. Let's see. So the sum of the first 40 numbers would be 40 over 2, and then what's 2a? Minus 8. And what's n minus 1? And what's the d? So this will be 20 times 78 minus 8. 70, is it 1400? Okay. 1400. Straightforward, we're just using the formula.
But A is plus 2 now.
No, what's A? A is minus 4.
Oh, yeah. D there.
Example 6. I want the Sn formula for 1 plus 17 plus 33, etc. And I don't tell you where to stop, so just stop at n. So using the formula, Sn would be n over 2, 2a, what's that?
2.
Plus n minus 1 times d, 16. 2 and 16 can both be divided by 2. So what is Sn here? That's n times 1 plus n minus 1 times 8. So Sn is n times 1 plus 8n minus 8, which is n times minus 7 plus 8n. So you get Sn equals 8n squared minus 7n. If you tell me the n, I can tell you the sum. That's the idea here. Let's test it out. If I add the first two numbers together, what should my answer be? 18. Okay. 2 squared? 2 squared is 4. 4 times 8? 32. 32 minus 14 is 18. Isn't it? 18. Yeah. And so on. Actually, let's do an easy one. If I add the first number together, what should I get? Just 1. There's nothing else to add to it. So let's put in 1. 8 times 1 minus 7 times 1? 1, yeah.
Yeah.
So it works. Okay. Right, next example. Can I scroll down? Okay. Example 7. Minus 8 minus 13 minus 18 dot 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 minus 308. Okay, I've done a few examples now. I think you can do this one. I'll give you a minute, see if you can get the answer for this. What do you need to do first? Find n. Find n.
N equal to 61.
N is 61, is it? Now you need to calculate the sum though. Okay, do you nearly have the answer? Yeah, you got it?
Minus 239. Maybe wrong.
What did you get?
Minus
Yes, again?
239.
Seems a bit small. Let's have a calculation. So, you got the n by saying minus 308, yeah, equals a plus n minus 1 times d, which is minus 5.
Yeah.
Yeah, so what did you just get for the n? If you solve this, what did you get for n?
I got 61.
You got 61? You got 61 as well? So we're all happy at 61? Yeah? Yeah. So now let's get the sum of the 61 terms.
Yeah, it's a 61.
N over 2.
Oh, here I have a mistake.
Okay. 2a
Sorry.
plus n minus 1 times d. Yeah? And what does this work out to be? Minus again? Yeah? Yeah? Aoife, did you get this? No? What's your mistake? Do you see it? Oh, you didn't finish it. Okay.
It's a 169.
Ming, what's that? You got this, yeah? Okay, good. Right, next example. Example 8. I tell you the sum of the first 19 terms is 570, and the sum of the first 23 terms is 828. See if you can get me A and D. You got A1? Did you get D? I hate to break this to you, but I'm not sure that is one. D is 3, yeah? That sounds right. Yeah, yeah. So here you have n over 2, 2a plus n minus 1d equals 570. And n over 2, 2a plus n minus 1d equals 828. Now, I'll divide by 2 here. So I'll have a plus 9d. And I'll divide by 19. How many times does 19 go into 570, please? And Aoife, you could maybe type in 828 divided by 23. Okay, and then the second one? 36. Okay. So I can simplify these two into these two. Yep. Second equation minus first equation. 2d equals 6. So what does d equal? 3. And if you sub that back in here, you can get A is 3 as well, isn't it? Yeah. That's the answer. Example 9. Last example. Can I scroll down?
Yeah.
So this one here, I tell you that 7 plus 7x, 8 minus 7x, and 3 minus 7x. These are numbers that are forming an arithmetic progression. So, what must the x be? What do we know if we know they are arithmetic? The change is d. So the difference between the first and the second should equal d.
D.
And the difference between the second and the third should equal d. So therefore, 8 minus 7x minus 7 plus 7x, that should equal d, which should also equal 3 minus 7x minus 8 minus 7x. Because these are both d.
Yeah.
Yeah? Right. 8 minus 7, 1. Minus 7x minus 7x minus 14x. 3 minus 8 minus 5. Minus 7x plus 7x is 0. Nice. 1 plus 5 equals 14x. So, x is 6 over 14, which is 3 over 7. Then. Yeah? Okay, write that down, and then your homework, which you can start now. Yeah. 1a, 2a, 3a, 4a, 5a, you get the idea, 6a, 7a, 8a, 9a. What's wrong? Peter?
How do you normally get right there that exactly means they means me? Because you always get it for the assignment.
It's a talent. It's a talent I have. You were hoping that I'd run over and you wouldn't have to practice anything, right? Be honest with me. We always have practice time at the end. Okay, can I close this? No? Okay.
Okay, why?
Ah, come on.
It's a sequence now.
It's a very straightforward sequence.
Yeah, you can put it.
Can I close this?
Yes.